Okay, welcome. Welcome to Hot AI Papers, or Papers, as you prefer. It's a new kind of experimental show where I will tell you about some new or not very new or just good works in AI, just to enrich your overview, give you some additional knowledge, and just to help you to follow up with what's going on in the world. Like field grows exponentially. So here we are. I will try to keep it very short, and I'm not sure about the level, how difficult it should be. I mean, which level of knowledge should I expect? But I think with some iterations, with some feedback from audience, we can converge to the proper level. I hope so. So let's not make introduction very long and just jump into it. So the first work is from Google, and it's not very interesting as some new deep learning architecture or some crazy technology, but just some news like for very common audience about what to expect from Google and its main product, search engine. And you can see the title on the screen, and basically what it makes, it adds some text annotation to image search, which I find like killer feature. It's so expected and it was awaited for so long when you just can add comment to the image you search. And yeah, it's really cool. I don't want to discuss deep nude because it's a very controversial topic, but technically they did very good job. Like they prepared the website, all the services on the mobile application, and it was really good. And yeah, with such technology from Google, you can just search the image of girl and to add a comment like change close to nude, and basically it will work similarly, which is interesting and it's cool technology. Just looking forward when they will implement it. You can see the basic idea behind. They use general deep metric to compare the images, and they encode both the like search image and other images. Yeah, but now when they add text, they need to modify the architecture, and they find way to change it. They find new architecture which will fit this task, and they get pretty good results. And they're not perfect, but they're still like very promising. What's interesting is that they gave this task to the intern, I guess, which is very strange. I mean, it's strange because it shows a priority of this task for Google, and for me it's a really great feature, and it would make search engine much better, and it would help people all around the world. But they gave this work to intern, and the first author of the work is intern, which is strange, don't you think? Well, the second work is technically also from Google. They didn't pay me for this, but it's just interesting work, so why not? So you can see the title, and it's dedicated to the neural architecture search, which was pretty popular like I think a few years ago. And yeah, for people who never heard about it, it's basically teaching AI to build AI, or like training the network to propose a new network architecture. And here they just address this task for segmentation. And what's interesting here is this scheme, how they design this search space. It's basically such simple space allows to capture like variety of different architectures. You can see DeepLab v3, conf, stacked hardglass. I mean, you can imagine very popular UNet, right? It's basically just this part with some skip connections. So, which I found pretty interesting, just this search space itself. And idea, I think it was really good, just to try different combinations, because if people apply different combinations, why not to try to find optimal? I think it's the best one of them. And yeah, they are able to do this. So they find such a way how to combine these downsample and upsample layers. And basically it's very interesting that because it's different from conventional, let's say, UNet architecture, where we see like monotonic downsampling and then consecutive upsampling. Here we can see some like stairs, and sometimes it goes back and returns, like it's upsample for one layer and then goes back, which is strange. I mean, which is not intuitive at all, and obviously without such algorithm for an architecture search, unlikely someone would propose such a way, because it's very unusual, I would say. And of course, yeah, they're able to get state-of-the-art results for segmentation tasks. The next work is not from Google, it's from University of California in Davis, and it's aimed to controlled image generation. The authors explain the motivation in different ways, something about clustering and so on, but I see a great value of this work, particularly for controlled image generation. So you can see the title, and basically this algorithm consists of 3 parts, and I will explain what they do right now. So you see background stage, parent stage, and child stage. So they split the network for 3 parts, and they train it, as they say, unsupervisedly, so without any segmentation masks or whatever. So that first stage generates just background, second stage, which is parent stage, generates the shape of the object and like the position, while the last stage generates color and texture. You can also see it on the example of these cars, where we have this background first and the kind of shape with not very good texture, and then you have good object texture. And here in the video you can see very nice illustration how it works. That changing backgrounds, they can change background without touching basically the object on the foreground. Changing the parent, they change the shape of the object, which is currently the shape of the bird or the class of a bird. And changing child code, or this child stage, they modify the color and texture while keeping the shape constant. Looks just great. That's the results people from NVIDIA actually tries to achieve for a long time, and they really do a lot of work in this direction, and they already achieved a lot, and it's very nice to see some new people in there. I mean, some people from University of California who produce such great results. It's called FineGAN, and yeah, I just recommend you to familiarize yourself if you are interested in GANs, because it's something new and it's not from NVIDIA, which is quite rare. However, worth noting that according to the words of one of the NVIDIA guys, such algorithms works really good with images where you can clearly separate the foreground from background, and where you have like the single object in the foreground somewhere in the center of image. Then yes, it works perfect. But imagine some clustered scene, some occlusion, some, I don't know, crowd, and how it will change. What will it change? What if it's a landscape image? It's really difficult to predict and difficult to say, and it's a much more difficult task in terms of training. Yeah, and results are not so nice looking.